Notes for ellipses. We're going to start with example 5. And we've done this now with several of the different shapes with the circles and with the parabolas, where you have to put the equation from this general form, where it's just kind of all multiplied out, into standard form, where you can pick out the center or the vertex or whatever it happens to be for that particular shape there. So for this one, the numbers look big, but it works out pretty nicely here. When you complete the square, you're going to get the x terms together and the y terms together. So we'll get 9x squared and 54x together, or y squared and 40y together. And we'll stick that 37 on the other side. It'll become negative 37. And then when we go through, in order to complete the square, this x squared has to be a 1x squared, not a 9x squared. So we just factor the 9 out in front. Okay, factor the 9 out of the 54, I'll have a 6 in there. And we'll do the same thing for the y terms too. We'll factor a 4 out, so I'll have y squared plus 10y. And then this is where we complete the square, so you're looking at this middle term's coefficient of negative 6. We're going to take negative 6, half of negative 6 is 3, and then 3 squared would be 9. And we don't have to worry if it's plus or minus. The minus comes into the part where we go through and factor. But it's really not a 9, it's really a 9 times a 9. So on that left-hand side, you really just added 81. So we have to add 81 to the right-hand side. And then we'll do the same thing for the next one here. So for this 10, I'm going to take half of 10, which is 5, and add 5 squared, which is 25. But again, it's not really 25, it's 4 times 25, which is 100. So I have to add 100 to the right-hand side. So then if I go through and I factor this 9 is still out in front. Inside factors into square root of the first term, which is just x, the symbol from the middle term, which is minus, the square root of the last term, which is 3. Same thing for the next one, square root of the first term, symbol from that middle term, square root of the last term. And then just combine these like terms on this right-hand side here, and you're going to get 144. Now the equation for an ellipse has fractions in it, and it's set equal to 1. So we have to divide all of these terms by 144, which looks awful, but it works out pretty nice. So the 9 over the 144 is going to give you a 16 for the denominator. And the 4 over 144 is going to give you a 36 in the denominator. And now your equation is in standard form for you. Your center would be at 3, negative 5. My value for A would be plus or minus 6 underneath the y, so it's going to be long vertically. And then my value for B would be plus or minus 4. And then it's the same thing that we've done before. We can go through and plot the center there at 3, negative 5. Right, and from that center, we're going to go up and down 6. I'm going to go off the graph here. 1, 2, 3. Right, and then from that center, we're going left and right 4. And connect that with a somewhat smooth curve there. We can come up with the coordinates for the vertices here, either by counting from the center, or you can add and subtract those values from your center, your A and your B values. So that 3, we added and subtracted the smaller value, the B value, and we're still down negative 5. And for the other vertices, we started at 3, and from negative 5, we went up and down 6. So if I simplify these vertices, this is looking like 7, negative 5, negative 1, negative 5, 3, 1, and 3, negative 11. All right, and whatever other things that, we ask you to find. What's the length of the major axis? You would say it's 2 times 6, which would be 12. The length of the minor axis would be 2 times 4, which is 8. And really, that's all you need is vertices and center. So you'll see a few like that in the homework. You have to complete the square. Just be careful of this part right here where you have the 9 out in front and the 9 inside. It's really not a 9 that you added. It was an 81, and same with this one over here. That's a pretty common mistake if you make a mistake for these completing the square problems. So then let's look at this last example here in number 6. This one they give you some clues for, and they want us to come up with the equation. And I find a lot of times for these it's easier just to start to graph it. I'm going to use this same graph up here again just so you can see what it's going to look like. So they said the endpoints for the major axis are at -2, -1, and at 8, -1. Going to be down here. So if these are the endpoints or the vertices for the major axis, that means the center is going to happen in between there. So you can kind of just count up in between. That's going to be the center. So that center is at, looks like 3, -1. Or you can add your x coordinates together here and divide by 2. Actually, you'd be subtracting there because we want the absolute value. So -2 minus 8, that would give you -10 divided by 2. So you can find the length of that. I just count them up there. And then the minor axis has a length of 8, which means I'm going to have to go from the center up and down 4 units. All right, so that's going to be the length for the minor axis, the endpoints there. So we know that the value for A, that distance there, is 5. And the minor axis, 1, 2, 3, looks like 4. So the larger one is going to be your A value. The smaller one will be your B value. So I know my A, I know my B, and I know the center. And I think we have enough now that you can write the equation for this. So it's going to be x minus 3 squared, y plus 1 squared. And then we just have to figure out which term is going to have the A value underneath, the A squared value. And since it's stretched horizontally there, it's bigger along the x-axis. The x is going to have the larger value, which is that A value. And remember, it's A squared, so it'd be 25 and 16. And that's the equation then. You'll see a few that are like that in the homework problems. And then the next part, we're going to skip this because we're really just trying to be able to graph these things. If you take physics, or especially astronomy, you'll go through orbits as one of the big applications for ellipses, and eccentricity is a big factor of that. And what it is, it's just how close to a circle is your ellipse. Is it very circular or is it very elongated? And that value for E, eccentricity, the bigger it is, so the closer it is to 1, it's going to have a very stretched out or elongated look to it. The closer it is to 0, an ellipse that has an eccentricity of 0 is actually a circle. So, you know, these problems you could do, we're going to skip them for time's sake here. This one we could go through and set up. This talks about the oval office, and the oval office is actually shaped as an ellipse here, is I think what they're looking at. The ellipse at the White House. I don't know what they're talking about here. So the ellipse of the White House. So this is 616 feet. This is 528 feet. I don't know where this is. Maybe it's some kind of garden or something. Whatever. So if you think of this, if you center it right at the origin, just stick some axes in here. So it's centered at the origin there. Really, they're just giving us the A values and the B values there. So if this whole length is 528 feet, that means our value for A is going to be half as much, which is going to give us, is that the 528? Well, I have it the wrong way there. I drew on top of it now and I can't see it. There we go. So this is our 616. That's the longer one. So our value for A is going to be half as much, so it's going to be 308. And then our B value, that's in this direction, is this 528. So B is going to be actually half of that. That's the length of the minor axis. So half of that's going to give us 264. So if you write the equation for this, and that's what they're trying to get you to do, x squared over, since it's elongated kind of along my x-axis there, the 308 would be that first denominator there, squared. Y squared over the 264 squared equals 1, which is fine. Or if you square those values, they're gigantic here. 94,864. And then the second one here is 69,696. Yeah. So you could use that as the equation to go through and design that if you needed to. All right. So that's all you need for the ellipses. For the second homework set there, you'll have a few that you have to go through and complete the square for, not every single one. And then the last two problems, 49 and 50, are kind of like what we just did, where they give you a graph and you have to come up with the equation working backwards there. So you should be good.